In this video, we look at a credit card sample. This is just a credit card example for educational reasons. And so these numbers are not anybody's in particular, but we are going to treat them as if we are trying to understand where these numbers are coming from and relate that to the formulas for ordinary annuities that we've done in class. Okay, so in this video, I first want to start with just our definitions, of course. Notice that we have a balance on this card of uh, $3,663.23 has been charged to this credit card, and therefore this number here is the present value that we need to pay off. So this is our principal. Okay, we would like to pay off this credit card to a future value of 0, and we can see here that a minimum payment has been given, and I'm curious if we can understand where this minimum payment is coming from and how it was obtained. Okay, let's notice that we have some information in this problem that we've been given the days in a statement period. So typically we've been assuming n is equal to 12. Um, so that's our um, number of compoundings. We're compounding per month, making monthly payments. Okay, so that's probably consistent. 12 days in a statement period. I'm sorry, 30 days in a statement period is 1 month, compounding 12 times a year, or once every month, every 30 days. You can see here that the interest rate for what we've got is 19.99%. Credit cards have very high interest rates usually. And I'm curious to see if we can figure out where this minimum payment is coming from. Okay, now from class we have this particular payment formula. So let's see if we can make sure we understand the formulas first. So I will come over here to Desmos. We need to put in number 1, number 2, and compute present value. Know the present value, know the future value. We can use this formula to find the payment. Okay, so let's take a look here. We have, I'm going, sorry, to my calculator. We're familiar with n1. Okay, we know that it's 1 plus r divided by n to the n times t power. Oops, sorry. To the n multiplied by t. Okay, and we don't know some of these quantities. We know that the interest rate here, we can see it is 19.99%. That's the APR, so 0.1999. And then we're going to divide by 12 compoundings per year, right? And we don't know the time involved, so let's just, we don't know how long it was going to take to pay this off. They did not give us that information. So let's just assume that we would like to pay this off in, let's say, 5 years. So that would be our N1 value. Okay, it's going to be, just for typing reasons, there's a quantity called I, that is the interest rate per period. So if I write the letter I, here's the interest rate per period. So 1.665% is charged every month. And so each month is $3,663. What we don't pay off is going to earn 1.665%. Okay, so I could use this quantity here. Here is I, and I haven't really changed the problem any. We now know that N2 is equal to N1 minus 1. Okay, and then we need to divide by R over N, but R over N is this interest rate per period. So here's our N1 and our N2 values. And if we look back at our previous formula, the payment formula was FV. We want to pay this credit card off to a value of $0. The present value is the principal, that's the $3,663, and we know number 1 and number 2. So let's complete that now. We know that the PMT payment is equal to negative the principal 3663.23, and we multiply that by n1 and then divide by n2. Sorry, let me get rid of the... And this is saying that if we want to pay this amount, this principal, $3,663, if we want to pay that off in 5 years, that our payment needed to be, excuse me, $97. So let's see if we can figure out where this $36.63 is coming from. If we'd like to pay this off in 10 years, our payments need to be around $70. If you want to pay this off in 20 years, the payments need to be $62. If you want to pay this off in 30 years, doesn't look like I can get to $36.63 for my payment. Okay, so evidently this minimum payment, we can see that there's a problem with it. Let's say if we wanted to pay this card off in 10 years, right? Then we would have to pay $70 a month. Okay, let's double check these numbers and then try to put that $36.63 into context. So let's make this assumption that we're going to try to pay this card off with $70 payments a month. Okay, let's see if this number is making sense. We can go to our spreadsheet tool. We've done a formula to figure out that $70 was a payment that we should be looking for, and our principal is 3363.23. That's the amount we need to pay off. And after one payment period, that's 1 month, okay, that $3,663.23 was going to earn interest of 1 plus 0.1999 divided by 12, so that's the interest rate per period. So the amount of money we borrowed grew to $3,724, and then we were going to subtract our $70 payment. Okay, so after one payment, it looks like we owe $3,654. Okay, if we continue this process, dragging and dropping, you can see here that we tried to do the same thing. We tried to earn interest on the 336. Sorry, let me go back. I don't know why that didn't work. Hold on a second. Let's try to type that formula again. Maybe we don't have enough of a pattern. We wanted to take this amount. We wanted that to earn interest of 1 plus 0.1999 divided by 12, and then we're going to make our $70 payment. Okay, so after 2 months, you can see this is the amount that we're going to owe, and then after 3 payment periods, let's see how we're doing. Okay, you can see here that our previous amount earned interest, and then we paid $70. Now, according to our formula, the $70 payments came from by paying every month for 10 years. That's a total of 120 payments. So we need to keep this process going, right? And the spreadsheet tools make this pretty easy to do. Let's keep this process going for 120 or so payments. Okay, and if we look at how the $3,663 is decreasing over time with $70 payments, after 54 payments, 54 months, you can see that we're down to $2,887 owed. And then around 120 months or 10 years, we're down to $289. Because we estimated a little bit, we needed to go perhaps to a couple more months to pay this credit card off. Okay, so it looks like maybe 125. One more step. Yep, there's a negative. So it looks like we're going to pay this pay off somewhere around the 124th month. Okay, so a little bit, 10 years and 4 months, 4 or 5 months that we paid this thing off. Okay, so here is the problem with the bill that is shown, right? They said our minimum payment was $36.63, and we can see that if we tried to do that, if you only went back to the beginning and tried to pay $36.63, right, that the amount of money that we owed after 1 month increased, right? And so what you're seeing is that even if we try to keep paying that amount off for 10 years time at least, right, you can see that, whoops, sorry, I need to get the pattern going a little bit. So let's try that again. Let's go to this amount right here. Is this amount that we owed was going to earn interest 1 plus 0.1999 divided by 12, and we're going to pay the $36.63 that they recommend. And you can see that we have a problem here, that every month that we're not paying enough money to beat the interest. So the amount that we owe after 10 years has gone up to $13,000. Okay, and that's because this $36.63 is not enough to lower the amount that we owed that's earning 19.99% interest. So this credit card has a flaw in it, that you're never able to pay this credit card off at $36.63 per month. You need to pay somewhere around, if you want to pay it off in 10 years, you need to be paying at least $70 a month. Okay, so that is hopefully kind of just an example of how, I'll go back to the $70 payments. That's an example of how those formulas can be used to kind of help you understand how to, okay, this amount paid, how to pay off the credit card and understand the bill, okay, and what you should be paying. Okay, in the next video we'll look at the rate formula in our spreadsheets, and try to figure out what interest rate would have been needed to have $36.63 actually pay off our credit card. Okay, but $36.63 is not enough to pay off this credit card at all in any amount of time. So we'll look at the rate formula in the next video.